Hello and welcome. How are you today, guys? Are you ready for the full day of Angular experience today? My name is Bartosz Pietrucha, and I will talk today about Angular router and lazy loading. You can follow me on Twitter, and also you can check out my website. We do workshops in Poland about Angular Academy, introducing people to the cool technology which Angular is. So this is what we are going to talk about today. This is our agenda. To be fair, the title of the presentation is not full. I named it Angular Router Lazy Loading. Let's get lazy, but the full title is Let's Get Lazy Loading. So we will start from Angular Router basics. Then we'll jump into Angular Lazy Loading. We will talk about preloading and see how we can easily integrate it in our application. And lastly, we will see how router guards can help us manage the access and control the access to the particular routes. So let's start with the basics so that we are all on the same page when it comes to routing. Routing in single-page applications is a very common approach to provide the user with the best possible experience. And generally what it does, as you can see on this presentation, we can link the particular URL with the particular content on the page. So once the user traverses the application and changes the router, the particular components dynamically switch and the view changes as the user goes through the app. So in this case, you can see that we have a sample application. We can see the list of employees. And once the user would switch the route to the different URL, dynamically, the component would be exchanged so that the next state of the application loads. And it's not the case only of Angular. A lot of single-page applications work the same way. In Angular, we have a lot of built-in features, an Angular router, which we are going to talk about today. So what are the internals of Angular router? Basically, the most important thing to understand is that what Angular router does, it takes the particular URL that the user typed in and matches it against the router configuration and then produces the router state. So in this case, we have employees/1 plus configuration in this example will result in the particular router state. If the user switch to the different view, different state, the router state would change. And then accordingly, the component tree would update itself so that the application state would follow the router state. So as you can see, when I switch those two views, the router state changes. It's still a tree. This is the all possible router states, but they are always matched against URL and the configuration. So how to integrate it in our application? First of all, the most important thing is the router configuration that we need to provide to produce our router tree, the tree of possible states. So imagine that we have this example, employee container component, and we need actually two properties, a path and a reference to a component. And then every time the user would enter the URL that matches this particular expression, the given component would be loaded in the proper place. Which place? We will see in the next slides. So this is one of the most important parts. So you see I have the config object, and again, it consists of the JSON objects that configures each and every route. So again, once the user would enter the particular route, it will be matched against this configuration, and the router state would update. Not only the first part is required, but also we need to provide this file to Angular. What we use is router module that for root, and we pass this particular object so that Angular parses this configuration and knows how to interpret the URLs. How do we then traverse throughout the application? Okay, this is not the slide. Before we actually go into traversing and linking, we need to understand that there is a special directive that tells Angular where to render the particular components. So it is a router outlet. So the place where you would like to component in the particular place to be rendered, you use the router outlet directive. And in this place, the particular components of the given state would be dynamically inserted. So how do we navigate through the application? We have two possible solutions. We can do this programmatically in our component or service. We need to inject the router, and then we can call navigate and pass the URL that we want to actually go to. So it can be just an action bound to the button click or whatever you want. The second possible solution is to use a router link directive in your HTML template, and then you pass the particular URL that you want to go to. So we have two possible cases, like declaratively with the router link and imperatively with the router navigate. Okay, so we covered the basics of routing in Angular, but there's one problem. If we have a really big application, every module that we actually would be using to take the components out of this module and navigate through the application would be bundled in one big chunk. So you can see this is actually an output of Webpack bundle analyzer. In my example, we have 3 components which are all packed in one bundle. So if the user does not want to use administration panel because he would not be required, if the user would not use the admin panel because he is not an admin at all, it still would be loaded to the application. And you can check out the Webpack Bundle Analyzer. It's a really cool tool to show you actually what is inside your bundle, and the size actually is depicted with the weight of the particular module is depicted as the size of the rectangles. If you run ng-build stats.json, and then you run Webpack Bundle Analyzer and point out to this particular JSON file, you would see this kind of result in your application. So in our example, we have employee module. You can see that there's a bunch of files included in this bundle: home module, shared module, and admin module. And this is a smooth jump to the case of lazy loading. We want to divide these packages into smaller chunks. So our goal is to have something like that. We want to put a proper modules in different chunks and load them as we go, as the user traverses through the application. So in this case, I have main module, home module, and shared modules bundled in the main bundle.js. And other modules like employee and admin are packed into the separate chunks. What we need to do to actually enable this lazy loading in Angular Router. The good thing is that we require very little configuration change in what we see previously. Thank you, Adam. So we need to a little bit adjust our configuration. As you see on the left-hand side, we have the routing for the root. And we need 2 more routing configurations for our lazy loaded modules. So first of all, we need to say that our employees module would be lazy loaded. We use load children property in our configuration to point out to the proper file which contains our module. After the dash, we say the name of the module. And we need to point the particular path under which we want to tell the router that once you enter this URL, please load this module and parse its own routing configuration. So you can see it here, actually. Previously, when we had the component, employee container component, we had employees in the path. Because we have moved it to the root configuration, we need to remove it from this place so that it is relative to the root configuration. The same happens to the second path. We had employees dash ID, and we removed the employees and put it here. The same happens to the admin module. We say the main routing for root that under the admin path and then under the load children, we say this should be loaded once the user first time enters this path, and the name of the module is admin module. Routing for the admin module is also updated to have the empty path and the component. Can activate would be discussed in the further slides. And the last thing that we need to do is to update the moment we tell the Angular where are the configurations for our routing. Nothing changes to the routing for the root, but we need to use router module that for child and pass in our lazy loaded modules the configurations that tells how to then manage and parse the lazy loaded modules. So what is the difference between for child and for root? Basically, they both does the same thing. They take the configuration and loads them into the Angular. But for root also produces a router service. And we don't want to have multiple router services in our dependency injector in Angular, so that for child would only parse the configuration and would not instantiate next router instance. Okay, there's one trick that we need to also remember. Before we enabled lazy loading, we had in our main app module dependencies to our modules that we want to then lazy load. If we want to have true lazy loading, we need to remove those modules so that they are not packaged in the main bundle. So we need to remove the imports to say that there is no dependency to those modules. If we would leave this here, our lazy loading would work, but still we would have each and every module, JS files, bundled in the same chunk, which will be loaded once the user bootstraps the application. This is not our goal. We want to not only load the router modules, but also download and fetch those files later on as the user traverses the application. Okay, how do we deal with the bundling? Because we said about configuration and loading modules into router, but what about the process of creating those chunks? If you use Angular CLI, everything is out of the box. It's shipped with the Webpack plugin that analyzes the router configuration and creates proper chunks as your configuration says. So you see that this is the output of the building process, of serving process, and you see that there are a couple of chunks actually emitted by the Webpack, and they match actually our lazy loaded modules. So the cool thing is that we don't have to worry about the bundling. Once again, if you use Angular CLI, everything is done out of the box for you. So we talked about the router, the basics, what it does for you, and what is the purpose of routing. We said a few words about lazy loading, but imagine that we want to still have lazy loading, but we want to have some modules preloaded in the background once the user uses the application, and once he types the particular URL and the state, the modules would be already loaded. So still we would have both. We would have the benefit of lazy loading, but once the user will click the particular link to enter the particular state, the bundle, the physical bundle would be already there. So let's see how we can do this. This will explain us a little bit this idea of preloading and fetching these bundles. So the first step, we are fetching the initial bundle, the main bundle that contains all the shared and all the necessary modules to bootstrap the first initial view. Once we have it downloaded by the browser, it will be rendered and Angular will bootstrap the initial view. When the user actually is using the application and traversing through the home component, what we do actually, we are fetching additional chunks in the background. So it's transparent for the user. He doesn't know anything. He just uses the application as it goes. And then when we have this chunk already fetched in the browser, once the user would change the particular state, the lazy loaded part would be already there. So there would be no delay or waiting for the chunk to be downloaded in the lazy manner. So actually what the router does, it actually in the background asks the loader system to get these chunks to the browser. So this is the idea of lazy loading. And enabling it in Angular router is straightforward. It requires only 2 small changes. So you can see this is our routing configuration. And there are 2 important lines in this configuration. First of all, on the lower line shows us that we are passing additional configuration to our router module. We are pointing to a particular preloading strategy. In this case, we have implemented our custom preloading strategy. Angular ships out of the box with 2. It says either load everything or load nothing. But you can also adjust it, implementing your own preloading strategy, which we actually see in this example. To the router configuration, you can also pass additional data. They are stored under the data property. And this is not the part of Angular. This is just our token that we use to indicate that we'll see indicate that this module we want to have lazy loaded. How does it work? Let's see how this selective preloading strategy looks like. So this is a simple injectable, simple service that implements preloading strategy, which requires you as the developers to implement one simple function, which is preload. It takes 2 parameters, route and the load function. And then you can see we are checking if our route contains preload property. And if it's true, we will invoke load function. If not, we will return observable of null. So what it does, it says Angular, we're trying to lazy load and preload a lazy loaded route, run this preloading strategy, and check if we have preload turned to true. If then, we are calling load. If not, we are returning observable of null, saying Angular, okay, this is not the route that we want to preload. Finally, we can use router guards to add yet another functionalities to our routing, because imagine that admin module would not be ever loaded because the user is not actually permitted to use admin module. And what if the admin module is lazy loaded one? We don't want to actually load this module if the user would never ever open it, because the application would forbid him to open it. So for that, we can use router guards. Let's see what we can do with them. So imagine that we have home component already loaded in our application, and somehow the user clicks the particular link or the button to switch to the admin component. And we can activate guard that would say, if this transition could ever happen. And then we implement, for example, some security checks or whatever for our application logic is needed. But if this component is lazy loaded, we can never do more. We can never even do more. We can actually tell the router if it should fire the lazy loading of this module. So if the canLoad guard would say, no, the user does not have any permissions, the loading of the particular bundle would not even happen. 10 minutes. Great. So we'll have 5 minutes for the demo, because we are almost done with the presentation. So how can we implement the router guards? There are a bunch of different interfaces that allows us to convey the information to the Angular. In this example, you can see that I have auth service, which implements canLoad and canActivate. Both of them requires this class to implement particular methods. First is canActivate, which says if the transition can even happen between two states. And canLoad is a similar thing, but it says if, as I said previously, if we can even download the particular lazy loaded module. So in this example, we have implemented some fake logging mechanism that has the one single flag that says either the user is logged in or not. So we will see in the demo how we will manipulate this flag. But for you to understand, we just need to return either Boolean or observable of promise of that Boolean type, so that the Angular can decide if it can activate or can load the particular route. The only thing that we need to do right now is to add those guards to our configuration. I promise you that I will explain what canLoad and canActivate does. So in this example, our admin module is lazy load 1, and what we do, we pass the service from here to the configuration under the canLoad property. And what it does, it will run this guard to check if the conditions are fulfilled to load this particular module. So you can see this actually highlighted. The same happens to canActivate. So we have the same service that implements a different method and implements a different interface, and we put it under canActivate property to tell Angular if even if the module would be loaded, if it can activate the particular component. Okay, so we are done with the presentation. We have talked about routing basics, lazy loading, preloading, and the routing guards. So let's see how it works in practice. This is my simple demo application that has 3 different modules: the home module, employees module, and admin module. For now, the lazy loading is not turned on, so let's refresh the view. And you see that we have only one main bundle downloaded, because here we can see a bunch of different bundles that are produced by the Angular CLI and Webpack. And what we're interested in is the main bundle. Don't look at the particular sizes, because this is not a production mode turn on. It's a development mode. So the particular sizes of the bundles would be much slower once you build it in the production environment. So this is very simple. Once we open the employees, we can see that there's a form and a list of employees that we can manage. There's also an admin module, but still we have the guard that says you have to be logged in. We can switch it with this particular checkbox, but let's wait for enabling the lazy loading. So what we need to do is to update the configuration. So what I do here, I'm removing these paths here so that they will be referenced relatively to the main routing configuration. The same happens to administration module. I'm adding this particular code to my main routing configuration and saying that this is the place where I have my lazy loading modules. The same happens here. The last thing I'm going to do is to remove those modules from my dependencies and imports in root application module. So let me save it and see what happens. The Webpack is working. Okay, what you see here, we have two additional chunks because Webpack automatically analyzed the configuration and came to understand that we need to produce two more chunks which contain lazy loaded modules. So now I'm refreshing the application, and if I open the employees module, you can see that the chunk was downloaded only ad hoc. It was not there yet. So the same would happen to admin, but we have a guard which says we cannot fetch this module because we are not logged in. So we didn't actually tell the router and module loader to fetch this bundle. So we are not wasting our resources if we know that there is no chance that the user can actually open this particular route. So let's do one more trick. Let's enable preloading. So I have the same code here implementing the preloading strategy, which tries to match the preload flag. So if I turn it to true, let's see what happens. You can see that the chunk number 5, which actually is responsible for employees module, is already there. So if I open the lazy loaded module, this is just a fake REST call here. And this chunk, which contains the module, was already there. So it was preloaded by Angular. Okay, let's see what would happen to our admin module. Here, you see that can load set again, false, because we are not logged in. But we are faking the logging process, and for now, the user is considered to be authenticated. So what you can see here, we have a chunk number 6, because Webpack adds a numbers to the chunks starting from with its own strategy. So you can see that can load set true and can activate set true. But the clue here is, once I do this again, you would see that can load was not here again because the module is already loaded. The only thing that actually is here is can activate because the second guard was asked, can the user open this particular route? As if it's already loaded, we don't need to ask the load guard. We only ask the can activate guard, and it's set true. That's why this module has been actually permitted to be loaded. So that's all when it comes to the demo. To sum up, we have seen a lot information about the router, lazy loading, preloading, and the routing guards. When it comes to the presentation, he was quicker. If you have any questions,